Hey folks, welcome back to Precalculus. Today we're in Chapter 2, Section 6, and we're going to be doing some graphing. Okay, so this whole first page is going to be kind of your toolbox functions that I'd like you guys to make, just parent graphs, no translations, no stretches, shrinks, anything like that. Okay, so the first toolbox function that you're going to graph on this one, I'd like to see you graph f of x or y equals x. And the next one, I'd like to see you guys graph f of x equals the absolute value of x. And I'll talk in a little bit in a second on how to do those things. And the next one, we're going to be graphing f of x is equal to x squared. And then we are going to graph f of x is equal to the square root of x. And then the last two, we're going to graph f of x is equal to x cubed. And f of x is equal to the cube root of x will be our last graph. Okay, so what I want you guys to do is this very specific strategy here is I want you to make a table of values and then plug those x values into your function to make the overall graph. So for example here, make an xy table here for this straight line one, and we're going to graph -2 to 2. Okay, so now when we plug in -2, we get out -2, -1, we get out -1, and so on and so forth. Okay, when you plug those x values in, this is what your y value comes out to be. So we can go ahead and we can graph this parent function. And these parent functions that you graph are going to help you graph all the transformations here that we're going to do in a little bit. Okay, so what I want you to do right now is go through and make a table of -2 to 2 for absolute value, for x squared, the quadratic. The square root one's a little bit different. I'll help you guys out. We're going to want to make a table using only values that we can square root very easily. Okay, we don't want to use negative numbers. We want to use perfect squares. So maybe we use 0, 1, 4, 9, and 16, just so that when we square root those things, we get out 0, 1, 2, 3, and 4. Okay, and for this x cubed one, you'll want to use -2 to 2. That's perfectly fine. You can cube numbers -2 to 2. For the cube root, you want to choose numbers that are easily cube rootable. Okay, so choosing a number like -8 is going to be easy because its cube root is -2. And a number like -1 because its cube root is -1. And 0 and 1 and 8 and so on and so forth. So go ahead and pause your video and fill in the rest of these parent functions. Okay, now that you've done that, here's a brief look at my answers so that you can double check. You can pause your video if you need to, but you see the graph for absolute value is V-shaped. The graph for x squared is a parabolic. The square root function is this arc-looking thing. Okay, check your tables too. And you can see the cube graph, is S-shaped. And the cube root graph is also kind of S-shaped, but increasing at a very, very slow rate. So pause your video, check your answers with mine. Okay, now we're going to talk about the standard form for all the transformations that you're about to see. It doesn't matter what the graph is, it can be anything, but the standard form is always going to be A times f of something, B, x minus c plus d. Okay, and I'm going to draw your attention to the a is multiplied by a function. F just represents a function. It could be like a squared function like below, or a square root, or here's an absolute value. F can represent anything. Okay, b times the quantity x minus c. Notice the coefficient on the x is 1. That's going to be super important down the road. Okay, and then there's always a plus, or it could be a minus d, whatever at the end. Okay, so let's talk about what all those letters mean. Letter A is going to represent our vertical stretch or shrink. The letter D is going to represent our vertical shift. Okay, so notice anything on the outside represents a vertical. It's going to correlate directly to the y coordinate. Okay, C is going to represent our horizontal shift. Okay, notice that whenever something is added or subtracted, it's going to be a shift. And B, which we're not going to use a lot of right now, is going to be our horizontal stretch or shrink. Okay, horizontal stretch or shrink. And notice anything inside the function is going to be pertaining to the x variable or the horizontal component. Okay, so what we're going to do here, going through this these notes, is I'm going to pause the video frequently and ask you guys to pause it, and you're going to be graphing and making tables and everything. So I'm going to illustrate that by showing you how to graph this first one, the second one here, this x squared, okay, this parabola. Okay, so the first thing we're going to do is we're going to start off by making a table of the parent function. And if you need to, you can flip over and check the table for the parent function. There it is, -2 to 2, 41014. So let's go ahead and fill that in. And we're going to graph it in a dark color here. So we know that our parabola is going to look like this. Okay, now we're going to make a table for our final function by looking and seeing how the different a's, b's, c's, and d's affect the x coordinates and the y coordinates of our parent function. Okay, so as PEMDAS says, we're going to multiply before we add or subtract. Okay, so we're always going to be multiplying our x coordinate or our y coordinate by some form of an a or a b. We'll talk more about that in the future. Okay, and then we will apply our shift second. Our add or subtract will come second, because adding and subtracting comes after multiplication and division in PEMDAS. So let's take a look at our x coordinates first, our horizontal component. And if we look at our original equation here, I see I have no b. B is 1, so I don't need to worry about anything there. But I do have a -1 on the inside. It's kind of like this minus c right here. Okay, so that means my x coordinates are going to be slid to the right one. Okay, horizontal component c is 1. Everything goes to the right one. So I'm going to be adding 1 to all of my x coordinates. So all of my x coordinates, -2 to 2, now have become -1, 0, 1, 2, 3. Okay, now I'm going to look at my y coordinates and say, okay, what's affecting the horizontal in my original equation? So I see I do have a vertical stretch or shrink. It's actually a shrink because it's less than 1. So I'm going to have to multiply my y coordinates by 1/4 and then move them vertical shift down 3. So 4 times 1/4 is 1, down 3 is -2. 1 times 1/4 is 1/4, down 3 is -2. I'm going to write it -2 3/4. You can also write it as a -11/4 if you like. 0 times 1/4 is still 0. Down 3 is -3. Notice I already did 1. I know what happens when I multiply 1 by 1/4 and move it down 3. I'm going to get -2 3/4. And I've also already done 4. I know I'm going to get -2. So let's go ahead and grab a different color here. And I strongly encourage you guys to use different colors. And let's graph our final function. So our final function is going to look like -1, -2, 0, -2 3/4, about right there, 1, -3, 2, -2 3/4, and 3, -2. And we can draw our parabola now, which we should notice has a vertical shrink. It's been compressed by a factor of 1/4, and it has moved right 1, down 3. You can look at your vertex, right 1, down 3. There it is. Okay, so what I'm going to ask you to try and do right now is pause your video and see if you can do this one the same way, this one the same way, this one the same way. You can skip this one for now, and this one the same way, using your parent function tables and your transformation rules. Pause your video and give it a shot. Okay, we're back. And hopefully you've completed those 4 graphs that I've asked you to do, and now I'm going to do this one that I asked you to skip right here. Okay, so notice it's an absolute value, so I'm going to go ahead and pull the parent function table for absolute value. It's -2 to 2, and outputs 2, 1, 0, 1, 2. I'm going to make a new table for my final graph. Okay, but now looking at this, if we recall, and I drew to your attention, the coefficient on the x needs to be 1. Needs to be 1, but down here, we have a -1. So we do need to factor that off. And when you factor it off, you can't pull it outside of your absolute value. So it becomes 1/3 absolute value of negative quantity x minus 2 plus 1. And now we can clearly see, like, here's my A, my B is -1, my C is going to be right 2, my D is going to be up 1. Okay, so let's go ahead and do our x coordinates. Remember, PEMDAS says multiply first. Okay, we'll talk a little bit more about what happens when this is not a 1, but for right now, we can just multiply. Okay, so -2 times -1 is 2, and then right 2 is 4. -1 times -1 is 1, right 2 is 3. 0 times a negative is still 0, right 2 is 2. 1 times a negative is a -1, right 2 is 1. And 2 times the negative, 2 times the negative is -2, right 2 should give you 0. Okay? Sorry, I forgot to draw my parent function. I'll do that really quick so we can see it before I do my y coordinates. Okay, so now y coordinates, we need to multiply by 1/3 and then move up 1. So 2 times 1/3, 2/3. Plus 1 is 1 and 2/3. 1 times 1/3 is 1/3. Plus 1, 1 1/3. 0 times anything is 0, plus 1 is going to be 1. And we already did 1. We know we're going to get 1 and 1/3. We already did 2. We know we're going to get 1 and 2/3. 1 and 2/3. So I can grab my color here, and let's go ahead and grab it and draw the thing. So 4, 1 and 2/3, about right there. 3, 1 and 1/3, about right there. 2, 1, 1, 1 1/3, and 0, 1 and 2/3. And you can see your V-shaped graph has been vertically compressed, right 2, up 1. Now you're probably asking, what does this negative sign do? It looks about the same as the parent function. Well, it's not the same as the parent function. This graph has actually been reflected over the y-axis. The negative sign is going to reflect it over the y-axis. You may have noticed that in the order that I drew my points. I didn't draw them left to right. I drew them right to left. Okay, so this negative sign right here does mean a reflection over the y-axis. Hopefully, in your other examples, like this one, where you saw a negative out front with the A and a negative out front with the A here, you noticed your graph flipping over the x-axis. So if a negative is in front, it's going to be a reflection over the x-axis. If a negative is on the inside, it's going to be a reflection over the y-axis. Okay, looking at these next 3, you know more than enough to do all of them and be successful. Okay, so make your parent function table, draw your parent function in a maybe a pencil or a lighter color, and then make your final function table and draw your final function in color. But you should be able to do all of them. Don't forget to factor off this -1, but don't bring it outside the parentheses. But you should be able to do these 3. So go ahead and pause your video and do those 3. Now that you're here, you should be able to do all of these fairly straightforward and simple. Okay, they're all have different A's, B's, C's, and D's. Don't forget to make your parent function table, make your final function table, and graph both your parent function in a light color and your final function in a color. Or I'm sorry, your parent function in a light pencil and your final graph in a color. But you should be able to do these three. You should be able to do the middle three with no problem. And when you get down to the bottom, I told you we were going to visit this when the B was not 1. You don't have to do this one right now. Okay, so don't do this one. But then you can do the last 2. Okay, so you have 8 more graphs. Go ahead and practice those right now. Pause your video and get them done right now. Okay, this last page, we're actually going to go backwards, and we're going to be giving you the graph, and then we are going to be writing the equation for the graph from there. So what we're going to do is we're going to go ahead and do this page in class. Okay, you can give it a shot. You can very obviously see what shape each graph is and what parent function they should have. So you should be able to identify the parent function, and then maybe you can write out what you think the A, the B, the C, and the D is, and put those into the equation so that you can write out the Y equals. But we are going to do these in class, so no need to do anything right now. We will be going over in class, but I strongly encourage you to try it and see how you do. Thanks, and I look forward to helping you guys in class.